Series and Parallel Circuits Lab. Skills Objective: to assemble and test a series and a parallel circuit, to measure voltage and resistance for each component and use both data to calculate the current flow, to establish visual differences between both circuits and compare voltage and current values, to draw a schematic circuit showing voltage, current, and resistance. In my lab, I use 3 types of sockets. You need to make sure that your light bulb make contact with this terminal. Also, a very cool feature of this type of socket, and you can press this terminal to insert the cable. You can insert 2 cables. You can also use to place the probes of a multimeter and read the resistance and voltage. The second type, and to measure, like for example in this case I'm measuring resistance. You need to place the probes straight inside this plastic, making contact in the center of the metal screw. The third type of light bulb socket that I have is the one with spring. It's very easy to use. You just need to stretch the spring and insert the cable. Also, you can use it to insert the probes of this multimeter. Now let's go to the procedure on how to set up the circuit series. With the material provided on this tray, picture A, assemble the components on the whiteboard, picture B, and set up a circuit series as indicated in this picture C. Use a tape to place each component on the board and label each one. With the switch open, measure and record each light bulb resistance on your data table. You can watch my video, Series and Parallel Circuit Lab Overview, that show with more detail on how to actually measure each light bulb. Now, because they're in series, we are going to use the formula for our equivalent resistance or total resistance, and we are going to add all the resistance that we measure with our multimeter. So we are going to add and record in this column. Now, with the switch closed, measure and record each light bulb and battery voltage on this table. You need to turn off immediately after reading to prevent discharge the battery too quick. Now we are going to use the voltage and resistance to calculate the current flow on each light bulb and complete this table. To do that, you need Ohm's Law. So the formula for current is voltage over resistance. So we measure voltage and you measure resistance. So we can use this formula to calculate the current that is flowing on this light bulb 1. And you repeat the same process for light bulb 2 and light bulb 3. To find the total current, you can use what you measure when the circuit was closed, the voltage that you measure, and the total resistance of your circuit to calculate the total current. Now let's look how to set up a parallel circuit. We are going to remove all the components from the whiteboard, from the previous series circuit, and you are going to use the same materials, but you are going to assemble the materials a little bit different. Here in this picture D is showing how you are going to connect all the cables. In this case, I'm using alligator cables, alligator clips, but you can just insert in the, like press the terminals of these light bulb socket and insert the cables in the hole. Now with the switch open, measure each light bulb resistance just like you did with series circuit. Recording this table. And now we are going to add all these resistance by using the inverse of the sum of all resistance. And with the switch closed, you are going to measure the voltage across each light bulb. Also, you are going to measure the voltage across the 9-volt battery. It will be way less than that. And you are going to record this value in this table. Now we are going to calculate the current using Ohm's Law that is flowing on each light bulb, and the total current you are going to calculate using what you have measured for voltage and what you obtain by calculating the total resistance on your parallel circuit. Now this is an example of one student mine of her schematic circuit that she did for series circuit and for parallel circuit. So notice that she placed the voltage across each light bulb. The light bulb is represented by the zigzag symbol, which is the symbol for resistance. The voltage, the battery, is replaced by the longer line, a smaller line. This is the negative and positive terminal of the battery. And this student is showing all the values that she measured during this lab experiment. Some troubleshootings. So if you have any problem about measuring or your circuit is not working, it's a good way to check is that make sure that all metal connections of the entire circuit is in place, is making contact. Check for the screw sockets if it's loose. Ask for a screwdriver for tightening the screws. Avoid spinning the screwdriver on the screw head. It's going to blend the whole thing. To avoid measurement fluctuation, check connections. Keep meter probes still, straight. With the metal contact, especially if you are using the light bulb socket with screws. Do not leave the lights on for too long. The battery will discharge quickly. And clean your station before leave and remove all tape. So in this slide is showing how you need to present the results of this lab. This is for your series, this is parallel, schematic circuit for each one, and write a conclusion that should include your experience, the problems that you have, and how you found the solutions.